Assalamualaikum. I'm Ahmad Nazmi bin Aziz from 3 BMMA to stroke 1. This is all my group members: Muhammad Nazmi bin Muhammad Noor, Muhammad Iman bin Ismail, Ahmad Hazmi bin Zahari, Ilham Muzaffar bin Abdul Muttaq. We are from Group E, and our topic is semi-active suspension system. Suspension system is one of the main factors of a vehicle performance. Even though it does not involve in the vehicle speed, it is still the must-have feature in vehicle. Suspension system avoids all the driver and passenger in the vehicle from a road accident. Moreover, it maintained the vehicle's accelerating, steering, and braking abilities during on-road. Thus, this system provides riding comfort. Semi-active suspension is way better than active suspension as they compromise between cost and system performance. So this is the literature review for article 1 that is reviewed by me. The title is Comprehensive Analysis for Influence of Controllable Damper Time Delay on Semi-Active Suspension Control Strategies. The name of the article is Journal of Vibration and Acoustics, that is published on June 2017. So the methodology is quarter vehicle and continuous damping control damper models, control strategies, numerical simulation of 5 control strategies. The result is relief conflict between ride comfort and road handling. Next, time delay on the semi-active suspension system in both time and frequency. Delay mechanism of semi-active suspension system cannot be treated as same as an active suspension system. More control weight or variables of various time delays were required for the comprehensive comparison of controllable suspension system.
Assalamualaikum, my name is Muhammad Najmi. I'll talk about my journal literature summary. So for the title of this journal is Semi-Active Suspension System Performance Under Random Road Profile Excitation. Name of the paper or journal or the article is 2015 IEEE 2015 International Conference on Computer, Communication and Control Technology. Month or year publication of this journal is August 2015. For the methodology of this journal, first, modeling of semi-active suspension system is simulation model used in this study involve 4 elements with the vehicle model, control algorithm, current generator and MR damper model. Next, for full car model is developed based on a locally measured car. For control system is a skyhook and modified skyhook algorithm. The magnetological or MR damper was used as a damping element in the semi-active suspension system. MR damper was used to control the supplier current to the designed MR damper, and for the result, it have ride comfort performance for the passive semi-active suspension system, which is skyhook and modified algorithm. And next, it has comparison between semi-active suspension system performance and passive suspension system performance. Next is a comparison between skyhook controlled and modified skyhook controlled semi-active suspension system. And lastly is an evaluation on jerk, acceleration, displacement, roll rate and roll angle response.
My name is Ahmad Azmi bin Zahari. For this article, title is a new semi-active suspension system for racing vehicle. The name of this article from FME Transaction 2017. The month and year published is May 2017. For the methodology, first one is kinematic analysis of the original passive suspension system. Perform a kinetic study. This preliminary study is necessary to define the geometry of passive suspension system that will be starting point for retrofitting activity. Dynamic analysis of the AFCA model. This environment allow to study the dynamic behavior by using the mass and inertia properties. The third one is simplified mathematical method model. evaluate the law of optimal motion of the two crank. We study the behavior of the 1 degree of freedom simplified system. And the last one is 3D multi-body model. To evaluate the performance of the semi-active system, we decide to give more detail to our multi-body model in order to obtain a behavior as faithful as possible. For the result, first one is to enhance a passive suspension system with an electromechanical device in order to improve performance in terms of comfort, handling and safety. The second one is to develop a variable geometry suspension system of simple construction, small in size, which require reduced energy for its implementation and that is installable without substantial changes to the original passive suspension system through retrofitting operation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman bin Ismail and this is my literature summary. The title is A Model Predictive Approach for Semi-Active Suspension Control Problem of a Full Car. The name of a paper is 2016 IEEE, the 5th Conference on Decision and Control, CDC, and it was published on December 2016. The methodology are give extension surveys on semi-active suspension control, propose a classical control method based on the skyhook control to improve the ride comfort. Then several extensions of skyhook control have been presented in the past decades. Propose an LQ based clip optimal control. Some LPV techniques for semi-active suspension control problems have been presented. A fast MPC is designed for a half-car model, but the MPC controller is still designed based on a quarter-car suspension model. And the last one is a very few studies have been proposed to develop MIMO MPC semi-active control techniques. The results are within proposed MPC, the ride comfort of the vehicle behaves much better compared to the uncontrolled passive suspension. Next, proposed MPC improves the road hold, reduce the roll motion. And the last one is in the context of semi-active suspensions, it seems the MPC road preview does not introduce significant improvements with respect to MPC using road disturbance estimation. Moreover, the feed-forward action obtained by the MPC disturbance estimation introduces improvements over the case of absence of disturbance compensation MPC without W. That's all from me. Thank you.
The title is Adaptive Hybrid Control of Vehicle Semi-Active Suspension Based on Road Profile Estimation. The name of journal that I choose is Shock and Vibration Volume 2015. The month or year published is 27 May 2015. Methodology for this research: road model, the distance between the road surface and the base plate is typically defined as a function of road irregularities. Quarter vehicle model, the hybrid control strategy and corresponding quarter vehicle model are created, and analytical expressions for sprung mass, acceleration, tire force and rate speed with respect to road excitations are derived. Damping coefficient calculations (MOOP) is presented, and the calculation of damping coefficient for different road levels is described. Road estimation: the road level must be updated continuously during driving in order to successfully realize suspension control. And lastly, state observer design. The results for this research is rider comfort. To isolate the vehicle body and passenger from road disturbance, the performance in terms of two frequency ranges need to be improved. Road handling: this criterion measures the ability of a suspension system to maintain contact with the road surface. Tire deflection is normally chosen for use as a comparison metric. Next, the rate space represents the distance between the sprung and unsprung mass. This is a constraint for the suspension system. and under the assumption that the road input is a Gaussian distribution process and the whole system is linear. Lastly, skyhook and ground hook suspension systems for ride comfort and road handling respectively, the hybrid control is proposed.
For discussion, from all the general results, it can be seen that the semi-active suspension system is able to improve ride comfort performance of a vehicle significantly when compared to the vehicle with the passive suspension system. As for the comparison between the skyhook control and modified skyhook control semi-active suspension system, in terms of the overall performance, it can be said that skyhook controlled semi-active suspension system is better than the modified skyhook controlled semi-active suspension system. This is actually being caused by a low performance of modified skyhook control system in improving the pitch rate and pitch angle response. However, from the evaluation on the jerk, acceleration, displacement, roll rate, and roll angle response, the modified skyhook controlled system was found to be better than the skyhook controlled system.
For conclusion, the semi-active suspension system performed better than the conventional suspension system. However, the performance of semi-active depends on the algorithms used to control its variable damping element. In this study, under the excitation of random road profiles, the skyhook control was better than the modified skyhook system in terms of overall performance. However, in terms of the improvement of each response observed, the modified skyhook performs better than the skyhook system in improving the vertical and roll motions of the vehicle. So this is all our reference. For the first one is the first article, second is the second article, third for the third articles, number 4 is the fourth articles, and the last one is for the fifth article. Thank you. That's all from us.